Okay, hello, welcome back. We'll continue our discussion on several miscellaneous topics. So now, after login system, we'll talk about the locations. Okay, so these are mobile apps, and the keyword is mobile. So users take their devices and move around, and unlike desktop devices, of course, where we don't carry the desktops, we carry our laptops, but not in the same way. We carry our mobile phones, cell phones, almost everywhere. I mean, you go to shopping, you go on a hike, you do some other activities. Um, the device is with you, and you may want some contextual features or some geolocation information to be used. I mean, the users may want it to be used to enhance the user experience. So that's the key point here. So now we'll see how we can get the location from the device. And of course, there are other things like displaying maps, etc., which I'll not cover here, but it's fairly easy to read and understand after this point, after getting some basics. Um, okay, so we have a class fused location provider client that is from the Google Play services, and it provides a very convenient way to let the system make location requests and then provide that information to the developer or to the user through the code. Um, it The name fused location, the fuse part comes from the fact that it combines or fuses the device location information from GPS, Wi-Fi, and cellular network. And its goal is to provide a fast, accurate result with minimal battery drain. So it manages a lot of things behind the screens, like it usually create batches of location requests from multiple apps and fires the request at a regular interval, etc. So your device is not always calling for uh, location, um, and that is one of the very battery or power intensive operation you might have noticed. If you are running GPS, navigating on your phone, it drains your battery quite a lot. Yeah, so that's the idea. Anyway, so we'll simply use it. Again, there is a very nice abstraction, very nice layers on top, and we don't really have to deal with handling these things at the lower level. All right, so this client returns a location object, or I mean, we have a call on the client which returns a location object with a latitude and longitude information. So what do you do with that information? You can use it in this simple case. What we'll see is using the geocoder class, which can convert the lat-lang information to human readable address and the other way around. So you have a get from location, which takes latitude, longitudes, and converts it to a string. And in the other direction, you have a get from location name, which takes the string and converts it to lat-long. Okay? So here is an example. By default, the emulator was set to Google's headquarters, which is at this particular lat-long, and the address is 1600 Amphitheater Parkway, Mountain View, California, blah, blah, blah. So we'll build this app, which gives us this particular UI. Okay, so to get the location services, you need to add this line to your Gradle dependencies. So we are still in GMS Play Services, but now it's Play Services location, and the latest version is 17.10. Um, okay, so um, using locations requires certain permissions. There are two location permissions in Android: coarse and fine. Coarse gives you an accuracy of about a city block, and fine gives you the precise location, like the address we saw on the previous slide. So you should check for these permissions. You should have first of all ask these permissions in manifest, like it's shown here at the bottom. But you should also check for permissions every time your app is trying to use the location. That is because the user can go and revoke the permission through the settings app for your particular app. And it's if it's not there, then you would have a very silly logic. So make sure you check for it every time. So remember, with Android 6.0 and above, we started getting these dangerous permissions, that is the ones that require active conscious uh, granting of permission from the user. They are now at runtime. So you'll see a dialog like this. Location sample is asking for the device location. You can either deny it or allow only once, or allow always when using the app. These kind of permissions you can grant. Um, All right. So how do we use the permissions? So check for the permission first, and um, this is how you will do it. In your on create, you would ask to check self permission, which takes the permission that you are asking. In this case, it is the access find location, and check if this returns equivalent of package manager dot permission granted. And if it is not granted, then request for the permission. Otherwise, you have permission and then proceed accordingly. So this one, as we saw, it checks for the checks whether the permission is granted, and um, you know, it can um, it it creates. Okay, let me talk about the next one actually. Yeah. So when you request the permission, it should you should pass it a second or a third parameter, which is an int, any int greater than 0, which we'll use to identify the permission in the callback that handles the result of requesting permissions. So we'll see on request permissions result on the next slide. Yeah. Um, oops. So here, if it's not granted, simply request for it. That's all it said. Okay, so on request permissions result is the callback that handles the result of requesting the permission. For every request permissions call, like we saw on the previous slide, um, it will have uh, this one will be called, and then you can use a switch case or an if else, nested if else, um, to handle different different permissions. So that's where the code comes into the picture. Okay. All right, parameters of this method, of course, you have the request code, and then you have a string array of permissions and a matching int array of grant results. Um, and you can check each one of them in this particular method. So this int array, each int in that int array can be either permission granted or permission denied. Neither of these will be null, as it's indicated by the annotation here. Okay, so let's see, what are we doing here? If the request code matches request location permission, then um, and if the result length is greater than 0, then you check if the result is permission granted, and you call get location, which is going to handle, and I mean, which is going to be the actual method that tries to grab the location. Otherwise, we show a toast saying location permission was denied. Okay. All right. So now let's talk about what we need to do when getting the device location. Okay, so to get the device location, as we said, we'll use the fused location provider client to get the last known location. Usually, last known location is same as the current location because you're at that location, and if locations are enabled, your device will be internally pinging and getting your current location. So that is the last known location. If not, if the location has moved, then you have to implement some listeners, which I'm not going to cover here, available on the online documentation. Pretty straightforward to go to after covering these basics. So inside your on create, you would simply grab the fused location client like this on the location services, call get fuse location provider client, and it gives us this object. Okay, now we'll see what we can do um, on getting the last location. So get last location um, is a method that returns a task object, which is uh, actually an async task to fetch the location object. Um, and it allows you to add success and failure listeners. So here, this is an example of a success listener, add-on success listener. And what are we doing here is if the location is not null, um, then we set the last location to that location, and then we'll try to display the last location on the UI. Okay. If it is null, then we'll say that we did not get a location, so it was null. All right, so here we add a call to fetch address task with the geocoder and main activity, and call execute with the location on it. So geocoder, as we have seen, can convert lat long to human readable address, which is what we'll do here, but it needs to contact the network. So this call, that particular call where you grab the human readable address from it should not be done on the main thread. So that's why we need an async task or some other form of handling background threads. All right, so here is the code for that async task. It's an async task that takes the locations as parameter and strings as return values. We see here the constructor that takes the geocoder and a listener. So this listener is an on task completed interface that we created here, and its only use is to set the UI from the activity that implements it, because you should not touch the UI on um, on a background thread. Okay? So to follow that principle, we are providing this listener. So now the do in background method on the async task, what is it doing? It's grabbing the location 0 and it calls geocoder get from location and sends the location latitude and longitude on it. And um, it then grabs the location based on the lat long provided. Um, the third parameter is the max list of max size of the list. Here one is enough. So you can create multiple human readable addresses from the same lat long. It could be, say, the street address of the building or the name of the building, if it's a famous building like, say, the University of Utah main office or the White House or something like that. So that's how you can get a list of things, but we are just interested in the first one here. Okay, then inside that, once you have got that, check if the addresses were null or the size was 0. If it was, then no meaningful address was found. Then if it was meaningful, so if it was not null or not empty, then get the address, get the parts out of it, and the parts could be like the number, street, etc., zip code. So put all of them together on a string, the result message. Text utils joins all the address parts with a new line in this case. And then that is the final part you get, which you return from here. So just like get from location, you also have a get from location name, as we have seen before. We don't see an example of it, but it can be handled in a similar way. In the catch part, which was not shown on the previous slides, you can catch the IO exception, which means the service was not available, or an illegal argument exception, which basically means the lat long were invalid. All right. So now, how do you handle passing the results back to the UI thread? The on post execute in the async task, which is called, as it suggests, at the end of the task completion. In that, we call the on task completed method of the listener, which in this case is the activity, and pass it the address. So in the activity, we implement the on task completed, where we grab the result, which is passed from here, and then set the text um, to, to that particular address. So there is a text box which will show that value. All right. Um, so a little aside here, um, you can also add string formatting to your Android XML strings, where the XML string can be of this form, where you have the first parameter and it's a formatter. It's not. It's a placeholder, not an actual value. Here, stands for string, D stands for int, T stands for timestamp, etc. And here you will see the get string here takes multiple parameters. First one is the formatted string, and then as many number of or as many additional parameters as there are the formatter placeholders. Okay, I'll leave the details for you to read. This is where you can get them. All right, so that's all about locations for now. And I hope with this you are equipped to use it in your apps. So the UI here is like this. So you click get location, it does all the magic and shows you this address. Right, thank you.